is only 5,000. Because only 5,000 CFM is going back to my HU, I'll be adding a total amount of fresh air, which is equivalent to the value of supply. That is about 500 CFM. Is it clear? This chart is clear, or should I go back to this slide and explain you once again there? This should be a, more or less, it has become a monologue. I could see only Prathamesh, Prashanti, or one Srikant talking on all the questions. Sometimes Vaishnavi also. Okay. Now, coming back to this, as I explained, the compounding area is at the most positive pressure when compared to the adjacent two rooms. If you see, the compounding area was the air volume, what was pumped was about 1000 CFM, out of which 50 CFM is going as exfiltration towards wash area and 50 CFM is going as exfiltration towards change room. Thereby, even though I am pumping in 1000 CFM, I am only taking out 900 CFM as the return. Okay. If you see here, the filling area, my supply air volume was 2000. Correct? When I am supplying 2000, my exfiltration going out of these two doors were 50-50. And my exfiltration going out of this opening was 100 CFM. Thereby, my return air from the filling area has reduced to 1800. Okay. Now, coming to the packing hall, my supply was about 1000 CFM. I am getting additional 100 CFM, which is of a much better and higher quality from filling area. So my total return was 1100. But if you see the here, we have taken only 1050 because this packing area is once again pressurized when compared to the outside ambient. A 50 CFM of air is going out here, and hence 1000 CFM supply, 100 CFM infiltration, 50 CFM exfiltration. My return is 1050. Now I think for you the terminology infiltration and exfiltration is clear.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So whatever the air which is going out of this room with respect to this room only, with respect to this room, all these three are exfiltration. The same air, when with respect to this room, it will become infiltration here. Clear?
Yes, sir.
So once I have achieved by doing my heat load calculation, my air balancing, I would have achieved the system, the HU capacity, and HU will be accordingly to design with respect to this. Okay. Here, my HU is balanced. Let us assume this 5500 CFM, out of which around 10% of air, and this is coming as a fresh air. This is the ideal situation. What will happen if my exhaust is more? Then my fresh air value will also increase, right? Yeah,
Yes.
that particular time, what will happen? The fresh air value into the system will increase. Thereby, you will be achieving a better indoor air quality. At the same time, there will be wastage of energy. That also we have to look into. And for balancing this one, Wi-Fi select the blower capacity accordingly. And while balancing the system, whatever the air which is excess, so that has to be bleeded out at the HO level itself. Okay. Now, what is air balancing? Air balancing is a process of testing, adjusting the airflow within each clean room for achieving the desired supply air, return air, and also the room pressure. All these things I have explained more than 2-3 times now. The A2 units shall also be balanced for the necessary air volumes such as supply air, return air, fresh air, and exhaust air. That is, the exhaust air in this scenario will be bleed air. Okay. So after doing this particular air balancing, what is that we are going to do? Each of this HEPA filter, let us assume this as a HEPA filter. This is actually a swill diffuser here. This is a typical example what you have taken from the internet. This is a hood which measures particularly the air volume coming out of a 2 feet by 2 feet HEPA filter, grill, diffuser, whatever may be the type of our air distribution product. So for all these things, they'll be using a hooded HEPA. In earlier days, they used to use these anemometers, auto anemometers. There are other types like we have one more equipment like this. This is a flow meter. Can you see this one a stud like a piece here? That is to ensure that we are taking the velocities at the right level. This measuring tool should not be too nearer to the grill or too far from the grill. To get accurate values, there is a particular distance, either it will be around 1 inch or 2 inch from the grill. So the values drawn from this are taken at 5 different portion of this particular HEPA filter, and they will average it out. They will take the room balancing air volumes. Whereas if you go with a such hooded type, directly now it's all digital. If you place this particular hood, enclose this all areas tightly, then whatever the air which is pumped into this hood will be going out through the measuring station here, and accurately you will get the data on this particular screen. That will be noted down. And the same manner, they will be taking at the return air grills also. This is not an return air grill, but this is an anemometer. Anemometer, there it will be measuring the velocity across this particular grill, and then they will convert this. They will calculate the area. They will calculate the percentage of the blockage, and this can be measured in meter per second or feet per minute, and even in knots. After doing all this taking necessary measurement, this is a typical air balance report. Can you see the values here? Is it visible?
Yes, sir.
Yes, sir.
Okay. So the each grill, if you had seen earlier video, there each grill would have a particular number that will be assigned by a QA department. So each grill, if you have observed during your site visits also, each grill will have its own number. So that when they are doing this particular testing at the every room, they will take the number of grills, whatever the number is prescribed by the QA. This is for a production block. So they have taken the number. This is R1, R2, R3, R4, R5. They have taken 5 readings. And this is in feet per minute. It is at 320 FPM, 356 FPM, 338 FPM, 348 FPM, and 310 FPM. And they will take an average of this value, which is about 334 in this particular. If you see this particular diagram, can you see my cursor here?
Yes, sir.
Yeah, these are the, if this particular rectangular portion denotes the our EPA module. This is the place they would have taken at four corners and at the center. When they are taking this reading, there is one criteria. The delta between these two, all these five readings should not be more than plus or minus 20%. That means to say, at one corner, if I'm having 200 feet per minute, and on the other corner, if I'm having only 50 feet per minute, that is not acceptable. Whatever these values should be in a range of plus or minus 20% only. Then, if it is the values are not within 20% of variation, that denotes there is some problem inside the EPA filter or your diffuser, because the air is not flowing uniformly throughout the module. So that gives an indication for the HVAC engineer or a service engineer to go and check above the false ceiling what exactly is the issue, and they will do the necessary required maintenance for that particular filter module or whatever it is. Once they get all these average values here, that will be converted into the airflow. When you have the velocity, you know the area of the filter. Volume is equal to area into velocity, and thereby finally they will get the CFM per filter. If you see these particular values also, the least value is about 1336, whereas the highest value is 1471. Okay, here also the delta should not be more than 20%. Why these things are regulated? Because the point of doing all these exercises is to ensure a proper airflow within the entire facility and not to create any hot pockets, so that we are ensuring that none of our clean facility is creating a hot pocket, as well as the airflow is uniform toward the facility. Thereby, we are achieving the required particle count, microbial count. Everything is kept within the acceptable limits. This is the typical airflow balancing sheet. After doing this particular room, then it will be applicable for the similar way for all the rooms. Once they finish for all 5 or 6 rooms, whichever the HO is catering to, then they will balance the HO also. With this, we'll be closing from the air balancing part. If you have any questions on this air balancing, HVAC, HO, filter, coil, ducting systems, you can ask me. I'll be happy to answer.
Sir, how to qualify the HEPA filter, sir?
Qualification of HEPA filter, it is basically the HEPA filters will be, after installing HEPA filter, they'll be doing a integrity test. There are basically two things. One is we should get a uniform flow from the HEPA filter without any leakage. That is on the air side. On the integrity side, they will inject a chemical on the upper stream and they will scan at the downstream. If there is any damage in the filter, those chemicals will be coming out of the filter with the air mixture. They will identify that this is a mandatory thing to be done every 6 months within the facility. The other class, if you see, I had asked you one question, why we are giving 3 or 4 stages of filters before the air entering the HEPA filter. We would have a G2 filter on the peripheral of the technical area, G4 filter on the mixing chamber, F7 filters next to G4 filter. Then we'll have F9 filters. Only then the air will be coming in contact with the HEPA filters. This is because HEPA filters are use and throw filters, will not be able to wash and reuse them. So because of the cost effectiveness, we are using the other filters which are capable of filtering the dust at 20 microns, 10 microns, 5 microns, 3 microns, 1 micron. When the dust is eliminated at that particular level, only the fine particles will be arrested in the HEPA filter. Omkar, any question?
No, sir.
Subhadeep,
No, sir.
Lasya Priya.
No, sir.
So if you don't have any other question, thank you for your patience. And this will be the last point on the HVAC part. Tomorrow there will be 2 sessions that will be dealt by Mr. Sundar. Okay.
Okay, sir.
Thank you so much.
Thank you, sir.
Thank you, sir.
Okay, sir.
Thank you, sir.
sir.
Thank you, sir.
Thank you, sir.
Thank you.